right, my friends, these problems sometimes get a little challenging for people, but we can do it here. We're solving for a reactant in solution. So we're going to take this volume of groundwater, and we think it's contaminated with some tin 2 chloride. We want to know how much is going to be there. So we're going to react it with a known amount, a known concentration of silver nitrate, which is right here. And we're going to collect the silver chloride. Well, if we know the silver chloride concentration, the number of moles of silver chloride, we can use our stoichiometry and our molarity to kind of back calculate here. All right, so let's see if we can do this. Well, we do know we start off with 3.9 milligrams of the silver chloride. Okay, very insoluble. And so we know we don't deal with milligrams, we usually deal with grams. So let's do 1,000 milligrams are in 1 gram of the silver chloride. And we don't do any chemistry in grams other than weighing it out. We usually do it in moles, right? And so I do know that I looked it up. There are 143.32 grams are in 1 mole of the silver chloride. Okay, nice. Now I know that that's the case, and so I know that if I go back to the stoichiometry, I know that for every 2 moles of the silver chloride, then I'm going to make 1 mole of or I'm going to consume 1 mole of the tin chloride. All right, now we want to know this. It looks like our answer we want in milligrams. So let's come back out into grams using the molarity, which I looked up for the tin chloride. So tin chloride in 1 mole of the tin chloride, there are going to be 189.6 grams. And we're wanted this in milligrams, so I do know that in 1 gram there are 1,000 milligrams. All right, a little bit of a long dimensional analysis, but it's helpful. And so that's we're going to get these to cancel: milligrams of silver chloride, grams of silver chloride, moles of silver chloride, moles of tin chloride, grams of the tin chloride, and so we're left with milligrams of the tin 2 chloride. All right, and then the only thing we need to do after we do that math is we have to divide that now by that 250 milliliters. So they actually want that in liters. So let's just quickly convert that now. So 250 milliliters. And I do know that there are 1,000 milliliters in 1 liter. And so that's going to equal 0.250 liters. All right, let's get our calculators and let's do this. So we have here 3.9 divided by 1,000 divided by 143 divided by 2 times 189.6 times 1,000. And so I am left here with 2.58545 milligrams. Just get a bunch of decimal places there for now. I'm going to divide that by 0.250 liters to get me those units in milligrams per liter. So if I divide that by 0.25, I get an answer of 10.3418. How many sig figs do we need to worry about here? I have 2 sig figs right here. That's going to be what I'm going to have. And so my answer here is going to be 10 milligrams per liter. Put a decimal there. This is my answer, 10 milligrams per liter. Notice that we don't use the silver nitrate molarity at all. Just use straight up stoichiometry, use some volumes, and hopefully you get the same answer. So that's how these problems are. Not too bad, right? Just do some conversions. Again, this is stoichiometry. Just get that stoichiometry right. Let your dimensional analysis guide you. You should be able to do this. Better explanation than AI could give you, and probably better than the ALEKS people can give you for this.